All right, I hope your quiz went well and you felt like you understand congruent triangles and how to prove whether or not triangles are congruent with the 5 different reasons. You'll get your quizzes back next class, hopefully, and you can review any of that information. Because now as we move on, we're going to do something a little bit different, and it won't really be about triangle congruence for the second part of this unit. You can see right here that we're jumping to Chapter 5 for just a couple of sections. So today we're going to talk about Section 5.3 and Section 5.5, which is about inequalities in one triangle, triangle inequality. So we're going to be trying to recognize and apply properties of inequalities to the sides and angles of triangles. And we're going to use the triangle inequality theorem to identify and prove triangle relationships. So if you recall from lesson 1 on triangles in this unit, that the exterior angle of a triangle is equal to the sum of the 2 remote interior angles. Okay, well, we should be able to conclude then Theorem 5.8, which is the exterior angle inequality. It says the measure of an exterior angle, which in this diagram is 1, angle 1. So the measure of an exterior angle of a triangle is greater than the measure of either of its corresponding remote interior angles. So angle A is a remote interior angle, and angle B is a remote interior angle. So we learned before, okay, well if this was 50 degrees and this was 110 degrees, then angle 1 has to be 160 degrees because it's the sum of the remote interior angles. So if this is 160 degrees, isn't it no matter what going to be true that that measure, this exterior angle measure, will be greater than either one of these remote interiors? So yes, you can see that in fact, this measure of angle 1 will be greater than either of those remote interior angles. Okay, moving on, we also know from lesson 1 that an equilateral triangle has 3 equal sides, and from this it follows that it has 3 equal angles, or vice versa. We can extend this to apply to cases where angles and sides are not equal. So there are 2 theorems here, and what we've done is on the theorem sheet, these have been put together as kind of a biconditional. They're not necessarily biconditionals, but we've rewritten them because they both kind of imply the same thing. So 5.9 says, if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. And here it says, 5.10 says if one angle of a triangle has a greater measure, then the side opposite the greater angle will have the longer side. So if I show you this GSP really quickly, so here's a GSP. We can see this angle down here, angle B, or angle ABC, is 84.21 degrees. It's my largest angle. Over here, angle C is 32.75 degrees, and angle A is 63.4 degrees. Well, the largest angle is opposite the longest side, and then the smallest angle is opposite the shortest side. My medium angle is opposite the medium side. Of course that makes sense, right? As you open or make my angle smaller, if I make my angle really big here, then this side length opposite of it, so this is opposite, has to be longer. If I make my angle really narrow, so here it's a teeny tiny angle, then that side length has to get smaller and smaller. So large angle produces its opposite the longest side, smallest angle is opposite the shortest side. So that's what 5.9 and 5.10 tell us. Okay, then moving on, the triangle inequality theorem. So the triangle inequality theorem says the sum of the lengths of any 2 sides of a triangle must be greater than the length of the third side. So this is really nice color coordination here. The red plus the blue, the sum of these 2 side lengths must be greater than the third side length. The blue and the green side lengths must be larger than, the sum of those 2 must be a bigger number than the side length of QP. And then, of course, your green side length and your red side length must be longer than your blue. So again, going back to that GSP, look at these numbers here. Here's my side length. If I look at my 3 side lengths, do the sum, so the sum of these two, that's about 27, 28. That's bigger than 6.7. Here, if I add 13 and 7, approximately I get 20. That's bigger than 15. If I add 15 and 7, so I'm just approximating here, 15 plus 7 is 22. That's bigger than this. So that has to happen in order for a triangle to exist. So in order for a triangle to exist, the triangle inequality theorem must be true. So the lengths of two sides must be, the sum of the lengths of two sides of the triangle must be greater than its third side. Okay, so moving on. Can you explain why this is true? Why does that triangle sum inequality work, right? So I'm looking at this. Why does the, sorry, not this one, the triangle inequality theorem work? Well, if we look at this example here, it says use a ruler to draw a triangle that has sides of lengths of 10, 4, and 5. Well, right here, is 4 plus 5 greater than 10? No. So we're saying from that triangle inequality theorem, that means this triangle does not exist. Well, if we look at GSP, so we look at our GSP, and here's that triangle right here. So I have AB as close as I could get it. This is a length of 10, and I have BD, which is a length of 4, and then I have another segment here, which is a length of 5. Well, what do you notice about these two segments? Their sum is less than the third side. So therefore, what happens to this triangle? It does not exist. It's not possible to create it because those two sides will not touch to form the third vertex. So you can use a ruler and demonstrate that. You can do a sketch, but write something right there. Those two sides right here are not going to reach each other to make the third vertex. Okay, so use this information we just discussed, or you just learned about, to try and complete questions 1, 2, and 3. So pause now and try to do these on your own, and then you can unpause and see how you did. All right, so hopefully in these first few examples, or number 1 especially, was very straightforward, and let's see how you did there. So we gave you a triangle ABC. We told you angle A was a 90-degree angle because of the symbol here. We gave you angle B is 40 degrees. Therefore, you know that angle C has to be 50 degrees because these are complementary. So what is my largest side? Well, my largest side is opposite my largest angle. So if angle A is my largest angle because that's 90 degrees, then my largest side is BC because that is the side opposite angle A. What is my smallest side? Well, my smallest side is opposite my smallest angle. So if angle B has the smallest measure, then the side that is opposite of it is side AC. So it is the shortest side. Okay, let's look at number 2. Number 2 says name the angles that measure less than the measure of angle 1. So here's the measure of angle 1. Well, this is an exterior angle of this given triangle PQR right here. So remember, we just learned the inequality theorem that said the exterior angle always has to be greater than its two remote interior angles. Well, this 4 and 5 together is one remote interior angle, and 7 and 8 together is a different remote interior angle, which means if they're being split somehow, then that means angles 4, angle 5, angle 7, and angle 8, all of those have to have a measure less than angle 1. The question is, what about angle 2? Well, just because our diagram makes angle 1 look like it's obtuse doesn't mean it necessarily is obtuse. It could be 90 degrees, it could be acute, so it's not necessarily going to be bigger than this angle right beside it. So you cannot always trust the diagram. So this is not necessarily true, so you only should list angles 4, 5, 7, and 8. Moving on to number 3. Can the following lengths be used for the sides of a triangle? Show your work. So show working. Well, here are my three lengths, 3, 4, 5. So you have to test all the combinations of the two side lengths, the sum, to see if it's greater than the third side. So 3 plus 4, is that greater than 5? Yes, it is. Is 4 plus 5 greater than side length 3? Yes, it is. And is 3 plus 5 greater than side length 4? Yes, it is. Therefore, yes, they can be used to create a triangle. Here, 10, 20, and 30, well, as soon as I do the first two, 10 plus 20, is that greater than 30? No, it's equal to 30. And it doesn't matter if it's equal to 30. It can't be equal to, it must be greater than. That's what the theorem tells us. In order to connect these two pieces here to create a triangle, these two measures have to be greater than the third side length. So no, this does not make a triangle. These side lengths cannot represent a triangle. And finally, question number 4. In triangle ABC, AB has a length of 8, BC has a length of 11. Find the range of possible lengths for AC. Okay, well, how would we do that? So first of all, we know that in order to create a triangle, the sum of these two has to be greater than x. So that's this part. The sum of those two have to be greater than. So 19 has to be greater than x. So in other words, x has to be less than 19. But how do I get the other end? You know, can x equal 1? Well, no, it can't be 1 because 1 plus 8 is only 9, and 9 is less than 11, so that doesn't work, right? So what about 2? No. So it doesn't work until you get to the number 3. And actually the number 3 doesn't even work because that equals 11. So it has to be bigger than, so the mouth is open toward the x, so greater than the difference of these two side lengths, but less than the sum of the two side lengths. So stop and think about that for a minute. Think about, again, why did I set this up this way? What am I trying to do? And then if you still have questions, make sure you follow up and ask your teacher. Okay, otherwise you can grab a book or continue with your laptop open, get on the student textbook and start doing these problems here, or ask your teacher some clarifying questions. All right, see you later.